A very nice little step 2 mechanics question here from 2011, question number 9. It's also question 4 from the step 2 mechanics support module. Two masses, a 2m and m, are heading towards each other. So I'll just say one's going to u like this and the other's going minus u in this direction. So it's actually going in this direction, but if I write it like this, I always do it like this. It just helps me to remember that it's a minus. And yeah, then afterwards they'll just have speeds v1 and v2. Again, if either are heading to the left at the end, then of course they'll just come out as minus. That's fine. Now, I've got two things to deal with here. We've got conservation of momentum, and we've got E is the speed of separation over speed of approach. So let's do momentum first. We have 2u times 2m plus m times minus u is equal to 2m times v1 plus m times v2. Cancel all the m's, and that simplifies a little bit to that. And then the next one is E is separation of approach. Always do the separation as this one minus this one, and then the approach is this one minus this one. So always right to left, and then left to right. When you're doing that, so it becomes this minus this over this minus this is just 3u, of course. Rearrange that for this, and then you can just, I think I just immediately added the two results together. Did I? Or no, sorry, I think I did this one. Yeah, sorry, this one minus this one, because that gets rid of the v2s. 2v1 minus v1 is 3v1, divide by 3 and you get v1 as this, and then just throw that v1 result into there, so it becomes v2 minus u minus ue, which is plus ue, and then take that away from both sides and add the u, and you end up with v2 as this. And that's all we have to say there, so that's excellent. And we could probably also notice that this is definitely heading to the right, because this is the same as u into 1 minus e, and 1 minus e is positive, and so is u. So this is definitely going this way. And of course, as this is going this way, this one can't have passed through it, so v2 is also going to the right as well, albeit faster, because otherwise, again, this one would pass through this one as it hit it. So okay, we've got those two things there. Now we know this one is going to the right, so it's going to hit a wall, it says, and the coefficient of restitution there is f. So we're going to need to set up a thing with this. It's obviously going to rebound. We're going to maybe call it speed v3. And we can say f is equal to speed of separation, which is v3 minus 0, I guess, because the wall isn't moving, over the speed of approach, which is, again, just this. And we have this. We can rearrange that for v3. And now we're basically back at the start, because we can ignore everything that's happened before. We have this mass of 2m heading to the right with this speed. And we have this mass of m heading to the left with this speed. So let's just pretend it's heading to the right and make that a negative. And we're basically back in the same situation we were right at the start, just with some slightly more complicated speeds to consider. And yeah, of course, they're going to have speed v4 and v5 at the end. So now let's just do the two things we did at the start. Conservation momentum, which is this times this plus this times this, equals this times this plus this times this. So we'll set that up. And then we've got we've got the E formula again. Now E is back to being E again, because we're colliding these two particles, which had coefficient E between them. So we've got E equals speed of separation. First, cancel all the M's and maybe do some stuff. Speed of separation is this minus this, over approach is this minus that, which just makes it a plus, I guess. And yeah, let's rearrange that for those two. And now all we have to do is get this thing to come out of it. So, okay, well, this thing is referring to the speed of B after collision. So that's V5. So I want to get V5 out of this. So right now, like if I just did this minus this, that will get rid of the v5, so I don't want that. So let's times this whole thing by 4. Sorry, by 2. I just read the 4 and said 4. Times by 2 to make these two things match. And now we can just add them together, and we'll get 3v5 equals all of this plus all of this. And of course, v5 is what they wanted us to be discussing here. So all we have to do is make this look exactly like this, after dividing by 3, of course, at some point. And if you look carefully here, there's some stuff cancels that with that, and then this, I think, as well, with the thing at the very end of that. So they write it a bit more simply. It turns out to this. And now we can just, I mean, we're basically almost there. They've got the U's together here and the stuff with F over there. So, okay, let's just swap those two over real quick. And then we can factorize out a U from here and an F from here, and actually an FU from here, I guess, as well, to make it look like this, and a 2, I guess, from there. And then when you divide everything by 3, I think you just immediately end up with what you're being asked to get. Thanks for watching. I'll see you next time. I actually just realized after looking through the video again that I had completely ignored this part here. Show that B moves towards the wall. In other words, show that B's velocity at the end there was positive, going to the right. So we need to show this thing is positive. Now, kind of unusually, of course, we're just going to set that to be bigger than 0. Kind of unusually, we're not going to use the formula they've given us. We're going to rewrite this maybe in terms of E squareds, like this. If I just, well, firstly, cancel out the U, because U by definition was heading to the right. It was the velocity of A to start with. So U is positive in our model. Times over by 3 to get this. Write this in terms of E squared like this. And now it's pretty easy to see from here that as long as F is bigger or equal to half, this is definitely true, because this is either positive or 0, and this is just positive. So if F is bigger or equal to half, that's all done. and whatever value of e, because e squared is always positive, obviously, that's all going to be fine. So what about values of f less than a half and between 0 and a half, I guess? Well, what we can say is, if we get out a very quick sketch, this number here is going to be negative. So our sketch in terms of e, if we're drawing the sketch in terms of e, and maybe this whole thing here, maybe I'll call g of e, the function of e. Because f is less than half, this is negative, so it's an upside down quadratic with still a positive y-intercept of 2 minus f. So it looks a bit like this. Now the roots, if I just add that to both sides, I'll get f minus 2, and then divide by this number here, and the roots will be there. So I've just pretended there's an equal sign here, move the stuff over, divide it, and square root it. Now, of course, when you square, you get a plus or minus, but e can't be negative. So while I've drawn this side of the graph, it doesn't really exist because e has to be between 0 and 1. And all I'm really checking for here is this value here ever less than 1? Because if this value was less than 1, then this whole function could be negative for some valid value of e. Whereas if this number here was bigger than 1, that would be fine, because that means the function itself was always positive between 0 and 1. Let's pretend it's somewhere like here, which are the only valid values of e anyway. So we just need to check whether this function here is bigger or bigger than 1. Now let's be super careful here. The top of this denominator is a negative number because f is less than 1. It's actually less than a half according to the bit we're actually looking at. And this is also negative down here. So this is a negative divided by a negative. And there's good news to that. It means that the square root does actually work because negative divided by negative is positive. It also means because this entire thing is definitely positive, I can just square both sides and the equality will hold. The inequality, I should say, will hold. So that's fine. Now I'm going to times both sides by 4f minus 2. However, 4f minus 2 is negative because f is less than a half. So when I times that by that, the sign's actually going to flip over. And now, of course, the minus 2's cancel, and you just end up with the condition that f needs to be bigger than 0, which of course is fine. So basically what I've said then is the only thing I need for all of the things to happen that I want to happen is f needs to be bigger than 0, but f is always bigger than 0, so it's fine. So therefore, if f is bigger than 0, then this root here is bigger than 1, which means that the valid case of e between 0 and 1 always gives me positive values of this function here. So therefore, the function is always bigger than 0, and therefore the thing is always going to the right. So probably the hardest bit of the question for sure there, just right at the very end. But thanks for watching.